Imagine an object so dense that not even light can escape its pull, a black hole. These cosmic enigmas are among the most fascinating and perplexing phenomena in the universe, capturing the imagination of scientists and dreamers alike. Their very existence challenges what we think we know about the fabric of reality. A black hole isn't a hole at all, but matter crushed into an unimaginably tiny space, so dense that it warps spacetime itself. This creates a region known as the event horizon, a boundary beyond which nothing, not even light, can return. It's a point of no return, where the known laws of physics break down. Black holes are born from the explosive deaths of massive stars, in events called supernovae. When a star runs out of fuel, its core collapses under gravity, forming a black hole. Though invisible, black holes reveal themselves by their powerful influence on nearby stars and swirling clouds of gas, pulling them in with irresistible force. These mysterious objects challenge our understanding of physics, representing the very edge of what we know about space and time. Scientists study the way stars orbit invisible centers and the strange signals from deep space to unlock the secrets hidden within black holes. To grasp their power, imagine compressing Earth down to the size of a marble. That's how dense a black hole is. Now, picture billions of suns squeezed into a space no bigger than our solar system. The result is a gravitational force so intense it shapes the very structure of galaxies. At the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. These giants anchor galaxies, shaping their evolution over billions of years. When two black holes merge, they send out ripples in spacetime, gravitational waves that we can now detect here on Earth. The immense gravity of black holes orchestrates the dance of stars, pulling them into rapid orbits. Sometimes, black holes unleash powerful jets of energy, blasting out into space and even halting the birth of new stars in their host galaxies. These cosmic engines are central to the grand story of how galaxies form, grow, and evolve. Their influence stretches across the universe, shaping the destinies of countless stars and worlds. To understand black holes is to unlock the secrets of the universe itself, and perhaps to discover the origins of our own existence within this vast cosmic tapestry. In the vastness of the cosmos, there are sights so extraordinary they seem to defy the very laws of nature, like the cosmic horseshoe. This remarkable object, discovered by astronomers peering deep into the universe, is a breathtaking example of the universe's ability to surprise and mystify us. But the cosmic horseshoe isn't a physical structure you could ever visit. Instead, it's a spectacular illusion, created when the immense gravity of a massive foreground galaxy bends and magnifies the light from a much more distant galaxy behind it. This cosmic trick of light forms what's known as an Einstein ring, a glowing arc that encircles the lensing galaxy like a celestial halo. This phenomenon, called gravitational lensing, was first predicted by Albert Einstein over a century ago. It's not just a beautiful sight. It's a powerful tool for astronomers, revealing the presence of something enormous and invisible lurking within the lensing galaxy. When scientists studied the cosmic horseshoe, they noticed that the lensing effect was far stronger than the visible stars alone could explain. This led them to suspect the presence of a supermassive black hole, one so massive, it dwarfed anything they had previously encountered in this region of space. Unlike the blazing, energetic quasars that light up the early universe, this black hole is dormant, completely invisible to our telescopes, detectable only through its overwhelming gravitational pull on the matter and light around it. The galaxy hosting this hidden giant is what astronomers call a fossil group. It's a cosmic relic, the last survivor of a galactic feeding frenzy, where one massive galaxy has devoured nearly all its neighbors, leaving behind only faint ghostly remnants. These fossil groups are like retirement homes for galaxies, quiet, ancient, and filled with the echoes of past collisions. Over billions of years, their central black holes have merged and grown, becoming some of the largest objects in the universe. In August 2025, after years of careful observation and analysis, a team of scientists finally measured the mass of this hidden black hole with unprecedented precision, using the subtle distortions in the Einstein ring as their guide. The result was astonishing. A black hole weighing in at 36.3 billion times the mass of our sun. To put that in perspective, it's more than 8,000 times heavier than the black hole at the center of our own Milky Way. This discovery places the cosmic horseshoe's black hole among the most massive ever measured. challenging our understanding of how such cosmic monsters can form and grow to such incredible sizes. The finding pushes the boundaries of what we thought possible, opening new questions about the limits of black hole growth and the history of galaxy evolution. The cosmic horseshoe is more than just a beautiful illusion, it's a crucial clue in the cosmic puzzle, helping us understand how galaxies and their central black holes grow and evolve together across the ages. How do you weigh something that emits no light? Astronomers use gravity itself. The first method, gravitational lensing. By analyzing the shape and brightness of the Einstein ring, scientists map the mass in the lensing galaxy. But to isolate the black hole's mass, they turn to stellar kinematics, measuring the speeds of stars near the galaxy's center. The faster these stars move, the heavier the black hole must be. In the cosmic horseshoe galaxy, stars near the center whip around at nearly 400 kilometers per second, evidence of a colossal mass. By combining lensing and stellar kinematics, astronomers can cross-check their results, achieving a high level of confidence. This dual approach is a game-changer, allowing us to find and weigh hidden dormant black holes. It opens a new window into the universe's most massive, mysterious objects. Now, we can uncover giants that don't reveal themselves with light. The black hole in the cosmic horseshoe galaxy is almost beyond comprehension, an astonishing 36.3 billion times the mass of our Sun. To truly grasp this, imagine a single object so heavy, so dense, that it outweighs entire galaxies of stars. For comparison, our own Milky Way's central black hole, Sagittarius A, is just 4 million solar masses, a giant by our standards, but utterly dwarfed by the behemoth in the cosmic horseshoe. The cosmic horseshoe's black hole is nearly 10,000 times more massive than Sagittarius A. It's like comparing a mountain to a pebble, an almost unimaginable difference in scale. Its event horizon, the boundary beyond which nothing can escape, would swallow our entire solar system many times over, stretching far beyond the orbit of Pluto and encompassing everything we know. To put this in perspective, if the Sun were the size of a grain of sand, Sagittarius A would be a bowling ball. But the cosmic horseshoe's black hole, that would be a truckload of sand, an overwhelming, almost absurd leap in size. Discoveries like this push the boundaries of what we thought possible. This black hole is so massive, it challenges our understanding of how such giants form and grow, and it's forcing astrophysicists to rethink the limits of black hole formation. All that mass is crushed into a singularity, a point of infinite density where the known laws of physics break down, and our understanding of reality is pushed to its limits. The event horizon is unimaginably vast, yet the matter itself occupies no volume at all. It's a cosmic contradiction, an object with infinite density, but no size. Black holes are true paradoxes, at once the largest objects in the universe by influence, and the smallest by volume. They embody the extremes of nature where the rules we know no longer apply. They're monuments to gravity's extremes, bending space and time to their breaking point, and reminding us just how much there is left to discover in our universe. Which came first, supermassive black holes or the galaxies that host them? The cosmic horseshoe's black hole is overmassive for its galaxy, suggesting it grew faster and earlier than its host. This supports the idea that black holes may have formed first, acting as seeds around which galaxies grew. Observations from the James Webb Space Telescope show that in the early universe, black holes often outpaced their galaxies. The cosmic horseshoe's black hole is a modern relic of this rapid early growth, linking ancient, overmassive black holes to those we see today. While telescopes find dormant giants, gravitational wave astronomy hears black holes merging. In 2023, detectors like LIGO picked up the most massive black hole merger ever, two giants merging to form a 225 solar mass black hole. The energy released briefly outshone the entire universe. These mergers challenge our theories of how black holes form and grow, revealing new ways massive black holes can arise. Together, light and gravitational waves give us a fuller picture of black holes' life cycles, from stellar mass origins to supermassive titans. The discovery of the 36.3 billion solar mass black hole and massive mergers is just the beginning. With new methods and telescopes like Euclid, astronomers will hunt for more hidden giants. Gravitational wave observatories like LISA will soon detect supermassive black hole mergers, revolutionizing our understanding of the cosmos. But this future depends on continued investment in science. Budget cuts threaten to halt our progress and close our window to the universe. The cosmos challenges us to keep exploring, to push the boundaries of knowledge. Discoveries like these remind us how much is left to learn. The universe awaits, if we dare to keep looking and listening.